this section 5.2, we're going to be talking about discrete and continuous domain. Now, in the previous videos, we talked about domain and how domain represents all the input values, all your independent variables, and basically your X variable. And this right here gives a little bit more description to what that domain is. So a discrete domain is a set of input values that consist only certain numbers. How did I write a P there? Only certain numbers in an interval. So you've been seeing these this entire time for these past several videos, as you've basically been seeing a graph, and you're going to see in dots in those places, those little points of ordered pairs. This is a discrete domain. It's one, two, it's just separate. Now we're going to be talking about something called continuous domain, and it's the set of input values that consist of all numbers in an interval. So look at the difference between the two here. They look very similar. It's basically the same setup. It's still going in that same direction, but notice how this one I have independent line dots here just going in each place, where this I have a solid line. So for this, it's going to be all the numbers in between, where the domain for this would be 0, 1, 2, 3, and 4 for my domain. The domain on this would be all the numbers between 0, and I'm just writing this out, all numbers between 0 and 4. So one of the numbers we could possibly use would be 1/2, or 3 1/4, or 2 1/2, or so forth. So that's how it means to be continuous. So how do we determine if something is discrete or continuous? We first have to ask ourselves, what is the context of the problem? Basically, what is the input, what it actually is, and how do we use it? And so this is where people get really confused at, because we have to really understand what the input variable is in the problem and how it's being used. All right, so I've given you two graphs right here, and our job is, and right now they look very similar, but one of these is actually going to be continuous and the other one is going to be discrete. So in both cases, I'm getting paid some money. So this is my Y variable. This is my dependent variable. My output is going to be money. Whereas in this particular problem, my input is hours. My X value represents hours, or my independent variable is hours. And this would be lawns, which would be my input, my independent variable, and my X values. So the question is, which is discrete and which is continuous? Well, think this one through. According to this graph, I'm going to be getting paid by the hour. Okay, so if I am working and I'm being paid by the hour, I can work 30 minutes and still get paid. I can work a half an hour and still get paid, an hour and a half, 3 hours, 3 1/4 hours, and so forth and so on. So I can still get paid by the hour. So and the reason is I can break hours down into smaller increments. So this is actually going to be continuous. And so because of that, I can actually graph this as a line. And it's not going to be the best line, so I'm not even going to try to do a perfect line right here. So we can actually graph this as a continuous line. I can get paid even if I only work at 2 1/2 hours. I still will get some money. Now let's look at this. I get paid per lawn. Well, if I go and mow a lawn and I only mow a half of it, will somebody pay me? No, because I didn't finish mowing their lawn. I get paid if I mow their entire lawn. So that would make this a discrete function. In order for me to get paid, I must mow the entire lawn. All right, so this would stay like it is. For one lawn, I get paid this much, 2 lawns, so forth, 3 lawns, so forth, 4 lawns, so forth. So this would be a discrete function because I cannot mow part of a lawn and still expect to get paid. So let's look at a couple of other problems here. So we're doing the same thing. Graph the function. Is the domain discrete or continuous? So we have an input of length written in inches and an output of area. So if we were to count, do this, let's see, what do we want to count by on our x's? 1, 2, 3, 4. Yeah, let's count by ones because we have plenty of room. And 2, 4, 6, no, can't count by twos. Let's count by 4. Let's see if that will work on my y's. 4, 8, 16, 20. No, I think 6 is probably going to be what we need to count by. 6, 12, 18, 24, 30, 36, and 42. So I've labeled my x and y values, and now I'm going to graph it. It says 2 and 12, so 2 and 12 would be here. And then I can do 4 and 24, which would be here. And then 6 and 36, which would be here. So my problem is this a discrete or continuous function? Well, think about it. My input is length and my output will be area. So can I only measure in inches? Actually, no. I can measure in feet. I can measure in a ½ inch. I can measure in a ¼ inch. I can measure in 1/32 of an inch. So what this is telling me is because I can measure in smaller increments than an inch and that it would still give me an area, I actually have a continuous domain. So I can actually graph it like that. Now, let's look at the next one. I have inputs of shirts. Stop right there. Before we even graph this thing, ask yourself this. Can I get a half a shirt? Not really. I can't get a half a shirt. I can't buy a third of a shirt. I can't buy even a fifth of a shirt or even 4/5 of a shirt. I have to buy a whole shirt. That's what this is. So my input would be shirts and my cost is my output. Right there, you should realize because I cannot buy part of a shirt, this is discrete. So that's really what you're asking yourself. Can I break my inputs up and still be able to use it? If you can, it's continuous. If you can't, it's discrete. So we can basically graph this. And for the sake of argument, we are going to go, we're going to do this as 1, 2, and 3. And then where we're going to go, the next one would be 925. This would be 1850 on this next side. And I'm not going to do the next one. So we know that at 0 shirts, we have to pay $0. At 1 shirt, it's $9.25. And at 2 shirts, it's $18.50. So this is definitely a discrete function. Now, I am actually going to give you the challenge problems of both 3 and 4 on this one. I want you to try these on your own. I'm giving you a function, an equation, and your job is to graph it using these domains, just like I did here. What you're basically going to do is you're going to create your input-output table and then plot your points, just like we kind of did up here. And then you need to determine whether it's continuous or discrete. If it's continuous, you're going to draw a line. If it's discrete, you're going to continue to keep your dots. Now, this one, I'm actually going to force you to show this one to me. All right? Please, I'm going to try to make sure that I have it in my notes that this is part of your assignment. You need to show me 3 and 4, okay? I need to see it, and I need you to talk to me about it because this is actually one of those things that I know confuses. All right, so that's it for this video, and I will see you in the next one. Bye-bye.